Okay, so whenever you're given a quadratic, just meaning that it's some kind of equation where it's x squared is the highest power. So x squared plus something x plus whatever. But really, we're just worried about that x squared. So whenever you're given a quadratic and they're asking you to solve for x, then you have three options. You can factor it, you can use quadratic formula, or you can complete the square. All three of those will show you what x equals or the x-intercepts, whatever you want to call it. So you would want to go in that order, though. You would always want to look at something and check, is it factorable? So basically you're going to look, okay, there's an invisible 1, so I'm going to find two numbers that multiply to get 40 and add up to get 14. Is that possible? Yeah, that's possible. So then I would not complete the square on this one. Nor would I do quadratic formula because it's factorable, and factorable is going to be the fastest way. But if you look at that and you say, okay, I can't think of two numbers that I could multiply to get 40 and add up to get 14, then do quadratic formula. Completing the square, honestly, I would tell my students, and I wouldn't tell them until after I taught them the lesson, but I teach them a lesson, I'd make them do their homework on it, and then the next class period, I would say, okay, forget what we just learned. I had to teach you that because state law tells me to, but really that's not useful. And that's kind of the same with this. It's your last resort. And the absolute only time you ever want to complete the square is if you have these two circumstances where there is a 1 in front of here, so an invisible 1, and this middle number attached to x is even. If you have something other than 1, do not complete the square. If you have a number here that is not even, do not complete the square. So those two checks have to work in order to even complete the square. So yeah, this one has a 1 in the front and it has an even number attached to the x, so we're good, we can complete the square. Now, to show you though that you could have done it quadratic formula or factoring, I'm going to go to the side and let's factor it. So two numbers that multiply to get 40 and add up to get 14 is 10 and 4. So then we would get x plus 10 and x plus 4. And if we were solving for x, or they'll often say, instead of solve for x, they'll say find the x-intercepts, or find the solutions, or find the roots. All of that just means solve for x. So roots, solutions, solve for x, or x-intercepts. Whenever they're saying those, that just means solve for x. Okay, so then that means that you just would set this equal to 0. So then I would have x plus 10 equals 0 and x plus 4 equals 0. So then I'd minus 10. X equals negative 10 minus 4, so x equals negative 4. So those are your two answers. Now, if I would have done the same one, and I would have done quadratic formula, which those numbers are kind of high, but had I done quadratic formula, I still would have gotten negative 10 and negative 4. Okay, so it does not matter which of the three methods you choose. You should always get the same answer. Okay, let's go through completing the square. So completing the square, again, has to start with a 1 and has to have an even number. Okay, that works. So we're going to set this equal to 0 since we're solving. Whenever you're going to be solving, if there's a y there, just pretend like it's 0. So cross it out and write 0. Okay, now if you are completing the square, that means, hold on, just give me a second. I have to remember how I explain this exactly. Okay, we're going to go over here, okay? I'm going to do a little example before we go over to this one. Okay, so if I wanted to make this a perfect square right here, so again, it's 1 and an even, so this one will be easy. So we then would have to find something to go here in this blank. So, but it has to be something that will make this whole thing a perfect square, meaning that when we would factor it, you're going to get the same thing in both of those. So then it just means that it's going to be something squared, because if you have something times itself exactly, then it's just that squared. So we're going to have x plus something and x plus something, but we don't know what those somethings are. So let's try and go back up here and think. So if I were to factor this, then I would find two numbers that multiply to get, I don't know. And those two numbers have to be the same and add up to get 6. So what number added to itself will give me 6? Well, that's 3 plus 3. Well, then if it's 3 and 3, then that makes this 9. So then that must have to be 9 if that's a perfect square. And if that's 9, then 3 and 3 were what worked. So x plus 3 and x plus 3. So then that's x plus 3 squared, because x plus 3 times x plus 3 is just x plus 3 squared. So we just completed that square by making it a 9. So you can add anything to it to make it a perfect square. Now, we just went through all of this work to kind of figure out how to do that. And you could do that every time. But really, there's just a formula. You divide this by 2, and then you square it. So that middle guy attached to x is b. So b divided by 2 squared will always get you that. So it was 6 divided by 2 squared. So 6 divided by 2 is 3. And 3 squared is 9. Okay, let's go back over to this. Now, when you have this right here, you move that over to the other side, okay? So the c value, it doesn't matter what it is. When we're completing the square, we move it over. So I'm going to minus 40. So I'm going to have negative 40 x squared plus 14, okay? So all I did is I moved that over. Now here, I'm going to complete the square, meaning that I need to figure out, oh, I forgot the x. That I need to figure out what would go here to make this a perfect square. And I can add anything I want, as long as whatever I add it onto this side too. Because you can add whatever number you want onto an equation, but it just has to be the same thing, because then it'll make the scale even. If you add something different, then that scale will be off. But your equation, we can add something here, and we just need to add it over there. Okay, so my formula said the middle one, so 14, whatever's attached to x is b. So 14 divided by 2, and then I square that. So 14 divided by 2 is 7, and then I have to square that, which is 49. So then 49 is going to go here, and it's going to go here. Now, once you do that work, just so you know, actually I'm not even going to show you yet. We'll look at it after. Okay, so now let's factor out this side, and it should be a perfect square. So two numbers that multiply to get 49 and add up to get 14. So now we know it has to be a perfect square because we just made it a perfect square. So it's going to be 7 and 7, which means that this is x plus 7 and x plus 7, which is just x plus 7 squared. And then over here we have 49 plus negative 40, which is positive 9. Okay, now if you look at this, this is, I believe, what you just did on your last section. You're solving for a perfect square. So then here I have, or solving square by square rooting, I think is what they called it. So if I have x plus 7 squared, I can just take off that square by square rooting, and then I'd have to square root this side. So then I'd get plus or minus 3. And this is x plus 7. Then I'd have to minus 7 onto this side. So I'd have 3 minus 7 equals x, and negative 3 minus 7 equals x. So 3 minus 7 is negative 4 equals x, and then negative 3 minus 7, oh, I wrote it there, is negative 10. And if you look, that's what we got from factoring, which look at how much work it took for factoring. And look how much work it took for completing this square. So that's why factoring is a lot easier. Okay, I'm going to do one more of those. So let me do one. Actually, I'm just going to do it, and it's not going to be a pretty one, which should be helpful because I don't think all of yours are going to be pretty. Okay, y equals x squared plus, let's do 12x plus 18. I don't know how this is going to work out. We're just going to go with it. Okay, so first thing, I put that into 0, so I'm just going to cross that out and write 0. Okay, and I'm going to check, is this a 1, and is this even? And even on your homework, because your teacher on your test is going to just say, solve for x. They're not going to say, like, use completing the square, or use quadratic formula, or use that. They're going to just have you do it, and you have to decide. Do you want to use factoring, quadratic formula? And I would tell my students all the time, don't worry about completing the square. Just do quadratic formula, or if it's factorable, factor it. Okay, but some students of my students actually liked this method, and they would do it. And I didn't care what method they used as long as they did one of them. This is my least favorite, but okay, so minus 18, just because it takes so much work that I'm like, okay, I'm a lot faster at other ones. Okay, we're going to have to plus a blank and then plus that same blank on that side. Okay, so we're going to do 12 divided by 2 and then square it, which is 6 squared, which is 36. Okay, so 36 minus 18, what is that, 12? No, that's 18, right? Yeah, that's 18. Okay, and then over here, two numbers that multiply to get 36. Added up to get 12 was 6 and 6. Now, I always made my students still do this just because they would forget positives and negatives incorrectly. So I still made them do it. So it was positive 6 and positive 6. Because if this were negative 12, let's actually do negative 12. Just so that I can show you. Sorry. So that makes that negative 12 and that makes this negative 6, which makes those negative 6s. I hope I didn't confuse you. I want to do a negative though. So if that were negative 12, I'd do negative 12 divided by 2, which is negative 6. Negative 6 times negative 6 is still positive 36, though, so it didn't change anything there. It just changed that and that. Okay, so then this makes this x minus 6 and x minus 6, which is x minus 6 squared. And then I would square root both sides. So I got to do square root of 18. I'm going to do it right here. So 2 and 9, 3 and 3. So a gang of 3 and a 2 is stuck inside. So 3 root 2 equals x minus 6. And then I would have to add 6. And if I add 6, this has a 3 root 2, so they're not like terms. So I just write the 6 out in front, plus 3 root 2. And really you could have written it as 3 root 2 plus 6. Is the same thing. Teachers usually just like it in the front. I would always tell my students it has to be in the front because they're so messy that sometimes that root 2 looks like it's, or the 6 looks like it's under that, which is not correct. This is separate from this. And that would be it. Okay, let me know if you have more questions. I hope that made it simple. Okay, bye.